In this video, we are going to go over hydration and dehydration reactions. So hydration and dehydration reactions involve water as a reactant or a product. In the hydration reaction, we add water to an alkane, a carbon-carbon double bond, and you hydrate it to create an alcohol. In dehydration, you remove the alcohol group and a hydrogen and form an alkene and produce water. So hydration reaction, water reacts with an alkene in the presence of a catalyst to form an alcohol. And dehydration reaction is the elimination of a hydrogen and a hydroxyl group from an alcohol to form an alkene. These reactions are catalyzed by lyases, which is a class of enzymes. So for a hydration reaction, water plus an alkene turns into an alcohol. So the hydrogen and the hydroxyl group from water are added to each of the carbon atoms in the carbon-carbon double bond. The double bond becomes a single bond with one carbon atom bonded to the hydrogen and the other carbon atom bonded to the OH. So you can see in this example, we can draw water as hydrogen bonded to a hydroxyl group. A hydroxyl group is bonded to one of the carbons that had the double bond, and hydrogen is bonded to the other carbon that had the double bond. When the alkene is unsymmetrical, the hydroxyl group from water adds to the double bond carbon with fewer hydrogen atoms, or you can think of it as the more substituted carbon. So this is an asymmetrical or unsymmetrical alkene. We have 3 carbons. The double bond is between carbon 1 and 2. When we add water, carbon 1 is bonded to 1 carbon and it has 2 hydrogens. Carbon 2 is bonded to 2 carbons and has 1 hydrogen. Carbon 2 has fewer hydrogens and more substituted. It is bonded to more carbons as well. And therefore, the hydroxyl group, or the OH, is going to bond to carbon number 2, and the hydrogen is going to bond to carbon number 1. Now, it can bond the other way as well. The hydroxyl group can bond to carbon 1, but this is what's called the minor product. So this is the major product. So the majority of your product is going to be this 2-propanol. But you'll also have some of this 1-propanol produced as well, but it's a minor product. A biochemical hydration reaction, the carbonyl group is usually next to the carbon-carbon double bond, and this directs the hydrogen atom to the double bond carbon closer to the carbonyl group, and the hydroxyl group to the double bond carbon farther from the carbonyl group. The carbonyl group itself is unchanged. So you have a double bond next to a carbonyl group. The OH is going to bond to the carbon furthest away from the carbonyl group, and the hydrogen is going to bond to the carbon bonded to the carbonyl group. Beta oxidation of fatty acids, you have the hydration reaction. It's a hydration reaction, and it occurs in muscle and liver cells, and it's part of metabolism of fatty acids. This provides hibernating animals with energy during hibernation. We have a fatty acid. It goes to fatty acid thioester in a reaction. The hydration reaction with the lyase enzyme, you add water and you create an OH group on the carbon furthest away from the carbonyl carbon and a hydrogen on the carbon bonded to the carbonyl carbon. And so you hydrated this fatty acid thioester. Dehydration reactions are when an alcohol is converted to an alkene and water is formed. The alcohol group and hydrogen are eliminated from 2 neighboring carbon atoms on the substrate or the reactant to form water, and a carbon-carbon double bond is formed between the 2 carbon atoms. You can see here that in carbon 1 2, and 3. Carbon 1, 2 is a hydrogen group on carbon 1, OH group on carbon 2. If these both leave, you get a double bond between carbon 1, 2, and 3, and hydrogen and water. Hydrogen and hydroxide bond together and you get water. Two possible alkenes can be produced when you dehydrate an unsymmetrical alcohol. The major product is the alkene with the fewer hydrogen atoms on the carbon-carbon double bond. But you can also have a minor product. So here you have an OH group and a hydrogen group on two neighboring carbons. The major product is when the double bond is between carbons from this OH group. The double bond can either go to the left or to the right. When it goes to the right, this double bond is between two carbons that have fewer hydrogen atoms. So this has one hydrogen atom here, one hydrogen atom here. There are two hydrogen atoms bonded to this double bond. Or if it goes to the left, we see that we have three total hydrogens bonded to this carbon-carbon double bond. So this is the minor product, and this is the major product. The major product has a carbon-carbon double bond between two more substituted carbons. So carbons bonded to more carbons than the minor product. Hydrogens next to carbonyl groups in a hydroxyl group 2 carbons away from the carbonyl group are eliminated as water is replaced with a double bond in a biochemical dehydration reaction. The carbonyl group itself is unchanged, but it is necessary for the reaction to occur. So we have our carbonyl carbon, hydroxyl group 2 carbons away from the carbonyl carbon. The double bond is going to go between the carbon bonded to the carbonyl carbon and where the carbon bonded to the alcohol. So it's going to go right there. And you produce water as well. So in summary, in a hydration reaction, an alkene is transformed into an alcohol. The hydroxyl group, the OH and H atoms form a molecule of water, add to the carbon atoms in alkene, and the carbon-carbon double bond becomes a carbon-carbon single bond. In a hydration reaction of an unsymmetrical alkene, the OH group adds to the carbon of the double bond that has fewer hydrogens, or you can think of it as the carbon of the double bond that's bonded to more carbons. In biochemical hydration reactions, an adjacent carbonyl group directs the hydroxyl group to the double bond carbon farther from the carbonyl and the hydrogen next to the carbonyl carbon. Beta oxidation of fatty acids is a biochemical hydration reaction, and it occurs in the muscle and liver cells as part of the metabolism of fatty acids. In a dehydration reaction, an alcohol is transformed into an alkene and water. The OH and H atoms from the alcohol are eliminated from adjacent carbon atoms, so two carbon atoms next to each other on the substrate or the reactant, to form water, and a carbon-carbon double bond is formed between the two adjacent carbon atoms. Two possible alkenes can be produced, and the major product is the alkene with the fewer hydrogen atoms on the carbon-carbon double bond. In biochemical dehydration reactions, the hydrogen next to the carbonyl group and the hydroxyl group 2 carbons away from the carbonyl are eliminated as water and replaced with a double bond. The carbonyl group itself is unchanged, but it's necessary for the reaction.